welcome back to my channel. Today we are gonna dive into super important topic in the system design, that is a scalability. Now scalability is crucial for building systems that can handle increasing amount of data and traffic. Whether you are designing applications, websites or cloud platforms, scalability is the key that they perform well under pressure. So let's break down what is scalability and how you can design the systems that grow as per your needs. Scalability in simple terms refers to the ability of the system, process or resource to handle increasing amount of work, or it is potential to expand. It is about how well something can grow or expand to its potential. It is about how well something can grow to accommodate more demand without a loss in performance and efficiency. So let's take a day-to-day example. Let's take an example of making pizza at home. Okay. Making pizza at home. Okay. So imagine you are making a pizza for yourself. Very easy, simple, and it is manageable task, right? Now, what if your friend somehow just came to your place unannounced and you have to make 5 more pizzas? If you can still handle to make more pizzas by making just one at a time, maybe increasing the speed or working a bit harder, your kitchen is somewhat scalable. For example, this is your stove and you are cooking pizza for yourself when you are only one. But after some time, you have to cook 5 more pizzas and you have only one stove. Okay. So you might increase your speed or maybe you work very hard. But even though if you can complete this is a scalable system. But you can do this only up to certain point. After some time, maybe your friends are hungry or you need to make more, then your oven is whole occupied and you are not able to serve as faster as you can and you will get overwhelmed. If you could somehow get another oven or maybe you can ask help from your friend, the process would be scalable. This was an example of needing to scale your ability to handle the increased demand of making more pizzas. So what is the key idea behind this is, so scalability means to handle growth, whether it is more pizzas, more users on your websites, or more customers in your business without the process of breaking down. So there are two types of scalability. First is horizontal and second is vertical. So we will go into depth of each of one and we will discuss its pros and cons, difference and when to use the horizontal or when to use the vertical one. Okay. So two types of scalability. First is vertical and second is horizontal. Okay. Vertical scaling is also called scaling up single server with increasing resources. So this involves adding more power to your existing resource or a system. For example, more CPU, more RAM or maybe more storage. You are essentially upgrading the hardware to handle the more load. So let's make this understand very simple and easier by the diagram. Maybe so imagine that you are at your home and few guests come at your place and you have to make a cup of tea for each of them. Okay, so if you are making a tea for 2 to 3 people, so imagine this is your pot and this is the flame of the gas. So it is simple to manage. Okay. But by chance more guests come over to your place. Maybe for example 25 to 30. So how will you do that? Maybe you will increase the size of pot and increase the gas flame. Maybe it would be stronger. And you can serve 25 to 35 people. Okay, you might add more milk, more sugar or more tea. So this is vertical scaling where you improve your current resources. Okay. So what are the pros and cons for this whole vertical scaling thing? Okay. So pros are this method is simple and doesn't require much more changes. You are still using one stove and the tea is relatively ready quickly. But what if around 50 or 100 people come to your place, then the size of the pot or maybe stronger flame won't help you. Maybe the ingredients like milk, sugar, everything will be like completed, right? And what if your stove breaks down in between? You won't be able to serve any of them. So I have also mentioned this in the notes and I will share these notes with you in the last. So please just pay attention and don't write anything. Just understand the concept and you can refer the notes after the completing of this video. Now let's take another example of the phone storage. Fine. So example second, phone storage. So imagine your phone is running slow and you are not able to take another photos because your storage is completed or it's full. So in vertical scale system, it is like upgrading your phone storage. You can buy a new phone and upgrading from suppose let's say 64 to 128 GB. Fine. You now have more space to store the photos without changing how the phone works. So this was your initial force, suppose 64 GB, and you have upgraded to the bigger storage that is 128 GB. Fine. So what are the pros for this? This is easy to do and your phone functionality doesn't change. You simply have more space for your photos. But at some point, even the 128 GB will fill up and you will need more space. The only way to get more is to buy a new phone with bigger storage. But that is expensive and there is a limit to how much memory a phone can have. So I have also mentioned this into the notes and let's move further. So what is the conclusion? The pros of using vertical scaling are vertical scaling is pretty simple to implement. You don't need to change the system architecture or the code. Since everything runs on a single machine, communication within the server is faster and the latency is slower. So you can take the screenshot of this. I have written all the 4 points and let's move forward to the what are the cons of vertical scaling. So this system also has the downside. You are limited by the maximum hardware capacity. You can add so much power before hitting a wall. Plus, if that server fails, your entire system goes down. So you can take the screenshot of this cones as well. And we are moving further. So let's just So let's understand vertical scaling by the example. So this is a particular system and these are all the components. So you can just imagine that inside this, all the components are kind of packed in one component and that's why the latency is slow and communication is fast. I My diagram won't be that good, but I hope you will understand this thing in very simple manner. Okay, so let's move forward and we will now understand what do you mean by horizontal scaling. The second is horizontal scaling. It is also called scaling out. Here, instead of operating a single server, you add more server to distribute the load across multiple machines. Think of it as a spreading the traffic across several smaller servers rather than relying on just one. So we will try to understand with the same example which we used on vertical scaling. Okay. So the example of making the tea for the people. So imagine there are only few guests at your home, suppose 5 to 15 guests. It's easier to make the tea for them. But by chance the guest size increase or maybe more guests show up your place, what will you do? In horizontal scaling, instead of trying to make the tea into the bigger pot, you can add more stoves and more pots. So let's take an example. So before in vertical scaling, what we did was there was only one stove with higher flame and there was a bigger pot you took for the more guests. But now in horizontal scaling, or maybe like this, huh, you can have more stoves. These are just take an example. These are the stoves, and these are the pots. and you are making tea for the people. So now each stove is making tea for smaller group of people. So this is horizontal scaling. You are distributing the load across multiple resources. So what are the pros of this? With this approach, there is no limit. Like for example, thousands of guests come at your place. You can just increase the size of you can just increase the number of the stoves and you can be able to serve them. Plus, if one stove breaks down, the others keep working. So you are not entirely dependent on single resource. But there are cons as well. This is more complex. You need to coordinate which stove is used by which person and make sure your tea tastes consistent across each pots. Similarly, in distributed system, you need to make sure that the system behaves uniformly even they are scaled out. So I have written all the points and you can refer them after the video is completed. So we will move to the second example which we took, that was a phone storage. So second example, phone storage. I guess I guess my handwriting won't be that nice, but it is easily recognizable like what has been written. So now instead of upgrading your phone to the newer phone with the like more storage, what if you start storing your photos into the cloud? So this is your phone, maybe, okay, and you are storing all your photos on this cloud, and I guess this is quite understandable. So in this case, you are using horizontal scaling. So instead of totally dependent on your phone storage, you are distributing your data to multiple cloud storages. These servers can handle as many photos as you need to store because cloud servers can scale out infinitely. So what are the pros of this? So this method is much more scalable. You don't need to worry about running out of the space, and if one server crashes, your photos are still safe on other servers. But it also have the cons. But now you are dependent on the network. If your internet connection is slow, uploading photos can take time. Plus, managing the data across multiple cloud services can introduce latency. So we can take an example of, suppose this is your phone. So we can just consider this example, and you are now in the network, and with the help of internet you are just uploading your photos into the cloud. But if the so even you might have experience while downloading the photos from the drive, it's kind of time consuming, right? So whatever terms or words which you find it's very new for you, for example latency and all the words, we will discuss about them into the upcoming videos in deeper. So just understand in the basic use case of the particular word. So let's talk about the conclusion of both vertical and horizontal scaling. Whether you are making the tea for a guest or managing your phone's photo storage, the concepts of vertical and horizontal scaling applies in everyone's life. Vertical scaling is like upgrading your current setup, bigger pod or more phone storage, while horizontal scaling is about spreading the load, more stops for tea or cloud storage for photos. Okay, so let's talk about the difference between both of them. So let me write vertical scaling and second is horizontal scaling. So first is the approach. So in vertical scaling, we are just adding more power to our single server, and in horizontal, we are adding more servers to distribute the load. Second, we are talking about the cost. This is expensive because it requires high-end hardware upgrades. This can be cheaper, commodity hardware, more machines. This is the first, this is the second, this is the third one. Third is complexity. So this is simple to implement. This is little bit complex because it requires load balancing, coordination. The fourth point is limitations. It is limited by maximum hardware capacity. And this is virtually unlimited. It scales by adding more servers. So we have discussed the four differences. Now let's come to the fifth. Fifth is fault tolerance. So here the fault tolerance is low because it is single point of failure, and over there it is high because if one server fails, the other server can take off. The sixth point is latency. So sixth point is latency. So this have the lower latency and the other one have the higher latency because it is just one machine and communication is kind of faster comparative. So seventh is use case. It is best for small and medium sized applications, and the other one is ideal for large or distributed system for higher traffic. So I have also mentioned in the notes, and let's talk about the last point. It is the 8th point, and the 8th point is scalability. It is limited by hardware constraints, while the other one can scale infinitely depending on the architecture. So I have mentioned this in notes as well. And let's talk about the common challenges faced in scalability. So some of them are data consistency, latency, and load balancing. Now, as great as scaling sounds, it comes with its own set of challenges. So let's talk about challenges of scalability. First is data consistency. So we are talking about this into horizontal scaling. So in horizontal scaling, the data consistency can be a trigger part, especially if your system is distributed across other regions. You will need to make the decision based on the cap theorem. So we will discuss about the cap theorem in the upcoming videos in detail because it is also an important topic, and I can't cover that into this video because it is all about horizontal versus vertical scaling. You will need to make the decision based upon the cap theorem. So cap theorem, we will understand that into detail in another video. So let's understand in the simple terms what do you mean by cap. It is like balancing between the consistency, A for availability, and P for partition tolerance. So second is latency. So as your system grows, network latency can increase. We have discussed that into the above diagram. So as you can see in the diagram, maybe your particular cloud or maybe particular system or server is into the another region. So to get the data from that particular server, it takes time. So that is called kind of latency. We will talk about that into the another video, but let's understand its basics. So as your system grows, network latency can increase, especially in globally distributed systems where the server need to communicate over long distance, which we understand by the diagram. Then the third is load balancing. This is one of the key component of horizontal scaling. It ensures that the traffic which is coming into the system is evenly distributed among all the servers. If this is not done well, then some of the server will have lot of traffic while some of the servers will sit idle, which is not the best use case. And now let's move to the another topic, that is, so now let's talk about scalable architecture patterns. So some of them are microservices, load balancers, and CDNs. To build the scalable systems, you need the right architecture patterns. Let's look at some of the most effective ones. So let's talk about the microservice application. So here, instead of building a monolith application, we are breaking down it into the simple, smaller, independent services. This is called microservice architecture. And here each service can scale independently based on its load. Second is load balancers. Suppose these are some of the servers, right? And here is the load balancer. So it makes sure that whatever traffic comes, so it distributes them equally. So here the common example is AWS Elastic Load Balancer. The third one is Content Delivery Network, that is CDNs. Content Delivery Network. So here there are lots of users. Just imagine, suppose lakh of users and whole server is in another country. Maybe here we are in India and this is suppose Australia. Okay. And we want to get some static data. So here We will place CDNs, and here are some of the servers. Okay. I'm just writing yes to understand better. So this CDN distribute the static content to the servers which are very near to this particular user. These are some of the user. So because of this, the latency can be reduced and so is the server load. So this is all about the CDNs in very like basic or shorter information I have given you. We will discuss about this into the upcoming videos in detail. So let's talk about the scalability in the cloud. Scalability in the cloud. So cloud platform have revolutionized how we approach scalability. With the services like AWS, Google Cloud, and Azure, you can scale your infrastructure on demand. This is called elasticity, where your system automatically adds or removes the resources based on the traffic. And the second is serverless computing. So I am just writing the topics elasticity and second is serverless computing. So here the example are AWS Lambda or Google Cloud Functions where the cloud provider manages scaling for you. So I guess these are enough for you to understand what is scalability. And let's talk about the best practices for scalability. Best practices for scalability. First is stateless design. So what do you mean by stateless design? They don't rely on the stored data from previous interactions. This makes it easier to distribute the workloads across servers. Second is database optimization. So in this, use the technique like sharding, read replicas or caching to optimize your database for high traffic. The third one is monitoring and alerting. Always have robust monitoring in your system. So tools like Grafana or AWS will help you to track system performance and scale proactively. So we are going to talk about every word which you find it very new. For example, load balancer, CDN and all the words. You can just comment down below. And obviously I am going to make another video and covering this all the topics or all these particular keywords into detail so that it is easier for you to understand all these components. So this is all about scalability. Let me give you the conclusion. Scalability is all about designing the system that can grow without sacrificing the performance or reliability. Whether you are scaling up or scaling out, the key is to understand your system's need and preparing for growth. If you find this video helpful, don't forget to like, share, subscribe for more content on system design. Also, if you have any kind of doubts, you can just comment below. Also about the notes, you might find it from my Instagram or maybe on the LinkedIn or else I will make the Telegram channel. Thanks for watching.